Carbon dioxide and water are both very common molecules on Earth. Carbon dioxide molecules are almost 2 times heavier than the water molecules. Yet water is a liquid at room temperature and carbon dioxide is a gas. What could possibly explain this crazy phenomenon? Non-metal atoms like carbon, oxygen and hydrogen bond by sharing electrons in what is known as covalent bond. Sometimes electrons are shared evenly, other times one atom will hog the electrons. Uneven sharing of electrons results in the formation of a dipole. A dipole is best defined as a separation of charges between two covalently bonded atoms. The atom that hogs the electrons will have a partially negative charge, often represented with a lowercase delta and a negative sign. The electron-deprived atom will have a partially positive charge, represented with a lower delta and positive sign. Dipoles are determined by examining the electronegativity values of bonded atoms. Electronegativity is the ability of an atom to draw electrons to itself. In other words, electronegativity values describe just how greedy an atom is for electrons. The more electronegative atom in a bond will always be the one with partial negative charge. When two elements have the same electronegativity, then there is no dipole. For example, H2. A molecule has a dipole moment when there is an overall unequal distribution of electrons across the entire molecule. Dipole moments are illustrated with an arrow pointing from the partially positive area of the molecule to the partially negative area of the molecule. A molecule like CO2 may be composed of two dipoles, but it has no dipole moment. This is because the charge is equally distributed amongst the entire molecule. When molecules have an even charge distribution and no dipole moment, then they are non-polar molecules. CO2 is linear molecule, so our dipoles are symmetrical. The dipoles are equal in magnitude but point in opposite direction. Generally, when dipole distribution is symmetrical, there is no dipole moment. However, when we draw the structure of H2O as bent, suddenly the dipoles are no longer perfectly opposite to one another. Dipoles point towards oxygen, indicating that the oxygen is partially negatively charged, and the dipole moments are not opposite, but they are going towards oxygen. Since they are going in one direction, they can be added up. So the molecule H2O will have a net dipole moment. So molecules that have an uneven distribution of charge and a net dipole moment are called polar molecules. On top of that, water has two sets of lone pairs on oxygen, making that area particularly negative. So water has the dipole moment. Therefore, it can create dipole-dipole interaction. Water has a special dipole-dipole interaction called hydrogen bond. Basically, a hydrogen bond is a dipole-dipole interaction. So hydrogen bond keeps the molecules closely together. But CO2 wouldn't have dipole moment, therefore it won't create a dipole-dipole interaction. Therefore, the CO2 molecules would be spread out. Due to this, the CO2 is gas and the water is in liquid phase. Which molecule or ion from those given below has the highest dipole moment? O3 is a polar molecule. The reason is the distribution of electrons across the O3 molecule is uneven, since the middle oxygen atom has to share electrons with two other atoms, but the other atoms only have to share electrons with one other atom. This results in the central atom having less electron density compared to others. Since ozone has a resonance structure, the electron density moves around the molecule continually. Therefore, central atom would have a formal charge of +1 and the other atoms would have a formal charge of -½ each. Ammonia has a chemical formula of NH3, meaning there are 3 hydrogen atoms for every atom of nitrogen. Ammonia molecules are laid out as a trigonal pyramid, with the nitrogen atom at the top of the molecule and the hydrogen atoms linked at the right angles. NO2 plus is a non-polar molecule because of its linear structure, which cancels out opposing dipole forces. This results in a molecule that does not have permanent partial charge. AlCl3 has a trigonal planar shape and it is non-polar. The dipole moments of each of the AlCl bond is directed at 120-degree angles to each other in a plane, and it is therefore cancelled out. Therefore, it is a non-polar molecule. ICl4- forms square planar shape. It is very symmetrical, therefore it has no net dipole moment, so it is not polar. So basically we have two polar molecules here, those are O3 and NH3. Basically NH3 is more polar compared to O3, so therefore the answer is NH3.